Folks, let's see what we remember from yesterday. We had our standard or our vertex form there, which is f of x equals a times x minus h squared plus k. Given our equation, f of x equals negative of x plus 4 quantity squared minus 5. Thoughts on the vertex? What do you think, Jayden?
Negative 4, negative 5.
Okay, negative 4, negative 5. Remember, you can think of it as hk, opposite of h. So if that says plus 4, we're going to use negative, and that's just because that's a minus sign in that formula. And then the k value minus 5. If we think real quick about the graph, the 4 is going to tell the graph to go left 4, and that 5 is going to tell the graph to go down 5. So you can think like that as well. Okay. What about the axis of symmetry? X equals negative 4. I reminded you guys yesterday that that axis of symmetry is still the first number in the ordered pair of the vertex, right?
Yep.
Hasn't changed. Old news, it's always going to be that way. So there is that connection there. Okay, next one. I need to know, I'll just write M, I guess, because we haven't talked about it. Is the vertex a maximum or a minimum, and what is that value of that maximum or minimum? What do you think here, Paul?
Maximum,
Why?
because the negative has a reflecting, so you got you going down.
Okay, because we have a negative out here. That negative is going to reflect my parabola upside down. And so this parabola opens down. And when it opens down, there's my little drawing. That puts the vertex at the top. If it's at the top, that means it is a max. So this is a maximum value. What is that maximum value? What is the highest point of that parabola, Patrick?
Negative 5.
Negative 5. Okay. You can think of it as it's always going to be the k value. And there is also the connection that the negative 5 is the second number of the ordered pair, yes?
Yep.
Always the y value. Let's see. I claim this is the easiest question just because it's the same thing every time. What's our domain?
Negative.
Okay. Negative infinity, positive infinity, or all real numbers. And lastly, range. Thoughts on range? What are you thinking, Ruby?
Negative 5 is a bracket.
Right pieces, wrong order.
A negative infinity is infinity.
Okay, infinity has parentheses, 5 has a bracket, negative 5 has a bracket. And here's your reasoning why, guys. Think about my sketch of the parabola here. My parabola is facing downwards, yes? So if we start low and work our way high, lowest is that my parabola is going infinitely down. So that's your negative infinity, all the way up to that max value of negative 5. Okay? If you're more of an inequality person, we could say that those values are y less than or equal to negative 5, because it is all values below negative 5. And again, I don't remember what Savas does there, but okay. So that sounds familiar from yesterday, right?
Mm-hmm.
That was one of the big new things we went over yesterday. Let's look at the back page. In this section, we are writing an equation of a parabola. Now, we'll have a couple different ways we'll do this throughout this chapter. This situation is given a vertex and one extra point. So if you know what that vertex is, and then one random other point that your parabola goes through, being able to write that equation. I will start us off with the fact that we know our vertex form of y equals a times x minus h squared plus k. Okay, that's the form we're using for everything here. And they ask us to write an equation of a quadratic function with the vertex 1, comma, -4, and passes through the point -2, -1. What are your thoughts here? Ruby?
H in 1, K in 4.
Valid? We know H and K?
Valid.
Okay. Vertex is H and K. So we know automatically, we're given the vertex, we know H and K. So at this point, I know my formula is y equals, I'm going to leave that A blank, x minus 1 for the H, quantity squared, plus K minus 4. Now, what about A? Put a question mark there for right now. Do we know A? We don't know A, do we? Maybe, maybe not, but it needs to be, there could also be a number associated with it.
-1.
Why?
Because the parabola would be upside down. Because the other point's -1 and -2. So it's kind of impossible for the parabola to go right side up. Point's down here. The graph's supposed to go like this. It will be upside down. So we have to have a number less than 1 as a.
I think I have to dispute you guys here. 1, -4, right 1. There's my vertex.
Oh, you're right. You're right.
Left 2, down 1. I'm going with my parabolas right side up. The negatives threw you off, I get it.
I don't know.
Okay. My point is, can we just guess at the A value?
No.
No. I mean, you can. Not as likely to get it right, because here, I'll give you a hint. It doesn't involve 1. It's not just +1 or -1. Okay. So, we need a plan here. How can we legitimately find A, short of just guessing? Keep in mind, they gave us extra information, didn't they? What do you know about an ordered pair? Okay, I like it. An ordered pair of any type is x comma y. What's my current equation I have? Y equals A that I'm trying to find times x minus 1 squared minus 4. So if I have an x and a y value, can I plug them in an effort to find A? Okay, that's our plan here, is that we're going to take this equation I have right here, and we're going to plug in x and y. And our job is to hopefully going to be to find A then. So it says y equals, for y I'm using -1, equals. A is what I'm trying to find. That's my variable at this point. Times x. What am I using for x? -2 minus h, which was already -1, quantity squared, plus k, which was already my -4. Okay. Do some math. What do we know?
It's -3 inside your parentheses.
Okay.
You start with those.
So starting with our parentheses, -2 minus 1 is -3. After we do what's inside the parentheses, we have to do exponents. -3 squared is +9. Now, negative times negative does make it positive. Don't let your calculator trick you, because if you put -3 squared in your calculator without using parentheses, your calculator is going to pop back -9 instead of +9. So be smarter than your calculator. Now, that's going to be 9. What is that 9 combined with? The A. So A times 9 is the same as saying 9A. And I write it like that on purpose, because I don't want you guys to fall into the trap of what to do next. How do I solve for A?
Add 4 over.
Add 4 over, right? So for anyone that was thinking, oh, I was going to do 9 minus 4, That 9 is attached to the A. Okay, so if it's minus 4, we are going to add 4 over. Negative 1 plus 4 is 3. 3 equals 9A. We're going to divide by what? 9. And 3/9, which reduces to 1/3. Okay, so my directions were to write an equation. What's my final answer here then?
Y equals 1/3. Parentheses x minus 1. Parentheses squared plus -4 or -4.
Okay. So your job to write this equation is to fill in h, k, and a. In the middle, we had to fill in x and y, didn't we? We had to fill in x and y to figure out what a was. X and y are not filled in your final answer, though. That's just our work. Okay, questions? Okay. Learn the process. It's not bad. You've just got to remember the process. Okay, changing it up already. Second example. Write an equation of a quadratic function shown in the graph. Are we doing the same thing?
Yeah.
Do we have a vertex?
Yeah.
Do we have an extra point?
Yeah.
Yeah, same thing, just different setup. So we're still using the idea of the form y equals a times x minus h squared plus k. What's my vertex? -2, 3, and so that means -2 and 3 are my h and k values. So if I was given an answer right now, y equals, we don't know a yet, but x minus, what's x minus -2? So that's going to become x plus 2, quantity squared plus 3. The question is, we don't know a. So what's that other ordered pair provide me with? Yeah, 0 and -1 are an x and a y value. So plug them in. Y equals, so I'm going to say -1 equals a. Okay, and for x minus h, so 0 minus -2, so 0 plus 2 squared plus k plus 3. Okay, 0 plus 2, 2. So -1 equals a times 2 squared plus 4. 2 squared? 4. And what is that 4 combined with? 4a. And again, I'm writing it as 4a because I don't want you guys to fall into the trap of 4 plus 3. And if I put that 4 after the a, I'm afraid you'll do that. If it's 4a plus 3, I'm going to minus 3. -1 minus 3 is -4 equals 4a. Divide the 4 away from the a, and a is -1. Okay, can you write your final answer? Y equals -1
Plus 2.
minus -2,
Right.
which becomes plus 2. Now, as I wrote that right now, y equals -1 times x plus 2 quantity squared plus 3. The one little tweak we can do is, do you have to write -1?
No,
You can just write a negative. So y equals the negative of x plus 2 quantity squared plus 3.
You take points off to write the -1.
I will not take points off if you write -1. Salvis? They might. I cannot read Thomas's mind very well. Sometimes I do, sometimes I don't. If you put -1 for me on the test, I'm going to be happy you got an A right, and I'm going to go with it. Okay. Got the idea?
Yep.
One more topic then? Okay. On this last section, we're going to reverse what we've been doing a lot. We've been looking at equations, and you've been telling me, okay, these are the transformations. These are the things done to the equation. Now, you're going to be given the transformations, and we have to write the equation. Okay? So we're kind of going backwards on that chart here. And so in our first example, let G be a quadratic function whose graph is a translation 2 units right and 5 units down of the graph f of x equals x squared. Write the resulting function g of x. Okay? So, they gave us a couple of translations. They told us the beginning equation is x squared, and they called it f of x equals x squared. We're writing the new equation. Okay? So, how do we show things like 2 units right and 5 units down?
We go back to our green sheet.
That chart that's on the front page of your notes, it was the green sheet from last chapter, right?
That 2 units right is actually -2.
Okay, so 2 units right, when it's left to right, it's opposite sign, yes? So that's going to be a -2. And where is that -2 going to be?
That's your x.
It's going to be with your x, yes? So I'm just kind of making myself some notes here. Because it's left to right, it's going to be directly with the x. So x -2 tells us we're going right 2. What about 5 units down?
-1.
Okay, we know 5 units down is a -5. Okay, so we've put that into equation form. It tells us to write the resulting function g of x. All that's saying is start with g of x instead of f of x. Okay, thoughts of what we want to write specifically? You've got all the pieces, it's how do we put them together?
Parentheses x minus 2 minus 1.
Parentheses x minus 2, then what'd you say?
Parentheses minus 1. It's squared.
And where's the squared go?
Outside parentheses.
Yes. Okay. So by putting that squared outside the parentheses, it's still an x squared, but that left or right motion has to go in the parentheses with the x. The -5 outside. This is very similar to some of the things we've been reading and working with, isn't it? That's final answer. Is that okay?
That's a twist.
Nothing wrong.
I don't know. When they give you more information, maybe? I don't know. Some of you, okay, so Paul sees this as easy. Now, here's the thing. Not everyone's going to think this is easy. Okay? So, let's try another one. Let G be a quadratic function whose graph is a reflection of the graph f of x equals x squared. So, reflection of the graph f of x equals x squared in the x-axis, followed by a translation 1 unit down. Write the resulting function g of x. Okay, so go through and think about what are the different pieces going to be here. How do we show that reflection? How do we show that translation 1 unit down? Thoughts, Logan?
Negative parenthesis x parenthesis squared minus 1.
Negative parenthesis x parenthesis squared minus 1. Did I get that?
Yeah.
What do you guys think? Okay, do we have the negative there?
Yep.
Reflection across the x-axis is just a negative out front of the x. Okay? Translation 1 unit down. That is a -1. It's not with the x though, is it? It's at the end. Now, I will take this. What's the one way I could clean it up and still have the same answer? What can we drop off of this? If you write negative x squared minus 1, that works also. Okay? So this would be the cleanest answer. I am perfectly fine with this answer. I never know about Savas. Okay? So could I possibly see Savas not liking the parentheses there? I could. They totally mean the same thing. I get it. But I could see them not liking it. Now, if we had a left or right movement, we would have to have the parentheses. But without a left or right movement, we don't have to have the parentheses. Okay, guys. Your homework is posted in Savas. Lesson 2.1. Get working. Due tomorrow.